Hmm. So, did I told any basic program of a prime number? Guys, we can discuss this program in how many ways, guys? Three ways. How many? Guys, am I audible? Please. Yeah. Right. We can discuss. Yeah. We can discuss this program in three ways. The one is, suppose if you want to judge n equal to how much? 23. If you want to judge n equal to 23 is a prime number, what should I do? I need to count. Guys, once you're done with speaking, please go on mute. Okay. What should I do? I need to find factors from 1 to 23. How many factors are there for 23? I need to find. Am I correct? Yeah. 1 to 23, how many factors are there? I need to find. Am I correct? After completing the, after searching of factors, after completing the finding of factors, then we need to see if my number of count equal to 2 is a prime number. Else, not a prime number. Suppose if you take 24, right? Guys, can you tell me what are the factors of 24? Come on. 1, 2, 3, 4, come on, 6, 8, 12. Okay. Then so on 24. Is it right? Okay. So do you find any factors from n by 2 to n? N by after n by 2, do you find any factor apart from n? Do you find any factor? No, right? No. Suppose if we take a number called 40. What are the factors? 1, 2, 4, 5, 8. Okay. 20. Am I correct? After 20, there is no factor. Am I correct till 40? Right? So what you observe is instead of going from 1 to n, you can directly go to 1 to n by 2. Okay. Right? I mean, not 1 to n by 2. You can go from 2 to n by 2. We already know my n is a factor. So if 2 to n by 2, if you find at least one factor, am I correct? We already know 1 is a factor and n is a factor. But in 2 to n by 2, after n by 2, there are no factors. It's a void. Okay, Gautam. So if you find at least one factor from 2 to n by 2, okay, my number is a prime number. Am I correct? Gautam, clear? Jayanti, are you clear? N is a prime. So the first step is we'll go from 1 to n, and second step is we'll go from 2 to n by 2. Here, if you find at least one factor, that is our third factor. Am I correct? So can you write the code for these two approaches? Huh? See, first one is I less than or equal to n. Okay. I think yesterday Bindu only told, right? She has Bindu, are you joining? Yeah, I think you only told, right? Sir, we have a shortage of power. It is dropping off. Is it right? See, Bindu, I am explaining for you again. Okay. What I am telling is, okay, we can we can count the factors from 1 to n for any prime number. Okay. So if you find at least my count equal to 2, that number itself is a prime number. Am I correct? So if you take 20 na 24, see here, if you take 24, my 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 8 is a factor, 12 is a factor. From 12 to 24, there are no factors. So we already know this 1 is a factor and n is a factor. But if you find at least one factor, okay, from 2 to n by 2, okay, then I can say it's not a prime number. Am I correct, Bindu? The first approach is we'll go from 1 to n. If the count of factors equal to, it is a prime number. The second approach is we'll go from 2 to n by 2. If the count of factors equal to 1, then break off the loop and you can directly tell it's a prime number. Okay, clear? Okay, okay. Bindu, fine. Okay. Okay, okay, okay. Fine, fine. No problem, no problem. I will have the recording. Okay. Right, yes. Okay. Right. So first we'll go from 1 to n. Okay. Right. So if my, yeah, yeah. Please go to, please tell me. Okay. Just a minute, just a minute. Yeah. Sound. Okay, my n is a prime number. Okay, clear, guys. N is a prime number. Okay. Else, my n is not a prime number. Okay. Okay. 23. 23 is a prime number. See, Gautam. Okay. So you can test for how much? Now 54. 54 is not a prime number, right? Okay. Now the same program I can optimize till from, let me copy this code. Two to see n by 2. Okay, na? If you find at least one factor, okay, then break the loop. Okay, see how I'm approaching. If my count equal to 1, it is not a prime number. Is that fine, Gautam, now in this context? Huh? It is not a prime number. If my count is other than 1, it is a prime number. Okay, correct? The same logic you can apply. Okay, that's it. See, we are going from 2 to n by 2. To find at least one factor, we can break the loop and coming out and judge based on that. If my count equal to 1, n is not a prime number. Else, n is a prime number. Clear? Thank you. 40? Yeah, why can't you take? 46 is not a prime number, na? See, clear, Gautam. Okay. Now the third approach is, so basically this is one of the question was being asked to me in Amazon, okay, earlier, 2, 3 years back, okay. So he said, okay, you have came from, suppose if my n equal to 100, earlier you have gone for 100 iterations, then you gone for 50 iterations. Even 50 is also a bigger number. Suppose if you're trying to fetch, if you're trying to do for, you're trying to do for n equal to how much? Some big number, 10 lakh. So if you do for 10 lakh or 5 lakh, both are bigger numbers only, lot bigger numbers. Am I correct, Gautam? So can we optimize further? Can we optimize further? That's what they have asked me. Okay. Hey, hi Kundan, how are you? Kundan, can you respond? Huh? Yeah, see, I was telling about the prime number program, okay, today. So prime number program, I was telling in 3 ways, okay, na? How many ways? First way, second way, and third way. Okay, Kundan. The first way is, if you want to judge my n is a prime or not, I am taking factors from 1 to till n, okay, na? So if my count of factors equal to 2, it's a prime number. The second way is, I am taking factors from, checking factors from 2 to n by 2. If my count equal to 1, okay, na? It is not a prime number. Am I correct? Because we already know one is a prime, one is a factor, and n is a factor. But if I find at least one factor apart from these two, then it's not a prime number. Kundan, am I correct? If you're not able to answer, please tell me. And third way is, and I'm about to tell that way. See, Kundan, what I'm telling, if you see 24, the number of factors are 1, 2, 3, 4, 6, 8, 12, then 24. If you see 40, the number of factors are 1, 2, 4, 5, 8, 20, then 40. There is a void from n by 2 to n. Am I correct? Clear? Huh? Yeah. Sure. See, can you tell me what are the factors for 24? Tell me. Factors, Kundan. That means which are divisible for by 24. The number which divides 24. See, Kundan, I am asking factors of 24, Kundan. See, 24 modulus 1 equal to 0. 24 modulus 2 equal to 0. 24 modulus 3 equal to 0. Am I correct, Kundan? 24 modulus 4 equal to 0. So if you see here, 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor. But 24 modulus 5 is not equal to 0, Kundan. Okay, na? So it is not a factor. So do you know the meaning of factor now, Kundan? Okay. Okay, na? That's the matter. Okay. So yeah, now we'll see. See, yeah, yeah. Kaise means इसके बाद what happen means, okay, 24 modulus 1. इसके meaning में 1 24 से 24. Am I correct? So the remainder is 0. Okay, na? So the meaning is, if you divide any number which is dividend, okay, by quotient, if my remainder equal to 0, that means modulus 1 equal to 0. Am I correct? Got it, Kundan? Vadina Chapu? Hello? Vadina Chapu? Second. ఇట్లా ఉంది నేను వస్తాను చిన్న పనిలో ఉన్నాను క్లాస్ అనకు వస్తాను ఓకే Okay, Kundan, now Did you got the meaning, Kundan? By this time, iske paas, I think you might be getting, okay, the meaning of the modulus symbol. So the modulus symbol will give me the remainder, okay. So 24 modulus 2, iske बारे meaning में, if you see 2 by 24, it will also 24, okay. Clear, Kundan? Tick. Okay, see, it also 24 and my remainder is 0, okay. So this you can write like 24 modulus 2 equal to 0. This is the meaning, Kundan, okay. Okay, na? Okay, right. So first approach is I have taken numbers from 1 to n. Second approach is I have taken 2 to n by 2. The third approach is we'll take the numbers from 2 to square root of n. Okay. If you see 100, okay, 2 to 50 is the second approach. If you see at least one factor, okay, के बीच में, okay, Kundan, fine. Kundan, can you please focus here? Please go on mute. See, Kundan, what I'm trying to say, no even or odd, Kundan, I am checking any number is dividing 100. When dividing 100 means remainder equal to 0. What I'm trying to say, iske beach between 2 to 2 to 50, if I found any number which is dividing my 100, which is dividing means if you found any number, while dividing that number, if you find remainder equal to 0, that means it's a factor. So in 2 to n by 2, if you find at least one factor, that number is not a prime number. Am I correct, Kundan? See, even or odd means that's different story, Kundan. Okay. 1, 2, 3, 4. 2 is even, 4 is even, 6 is even, 5 is not odd. Like that. Okay. So the number which is divisible by 2 is a even number. The number which is not divisible by 2 is an odd number. Clear, Kundan? Don't compare that with this. Okay. This is nothing but we are counting factors from 1 to n in first case, 2 to n by 2 in second case, third case is 2 to square root of n. Okay, na? Clear? See guys, for 100, if you want to find, instead of going for 2 to 50, I can go from 2 to 10 also. If you find at least one factor, I can say my n is not a prime number, okay? Am I correct, Gautam? Okay. Yeah. See, math dot square root of n, okay? See, I'm not going for n or going for n by 2. I'm just going till square root of n only. Clear? See, same logic again, guys. Okay, if you find at least one factor, you break the loop and come out and check if my count equal to 1. It's not a prime number. Clear? Not a prime number. See, guys, okay, na? And Kundan, I'm telling again, don't compare with even or odd. Okay, Kundan. In Hindi, what we call for compare? Guys, in Hindi, what we'll see for. Yeah, 23 is a prime number, okay, because there is no factor from, apart from 1 and 23, there is no number dividing 23, okay? 27 prime number nahi hoga, because if you take 3, 3 will divide 3 9 से 27, Kundan. So 27 prime nahi hoga, okay? क्योंकि if you say 27 modulus 3 equal to 0, if you see 3 27, 3 9 are 27, okay, remainder is 0. How come it is a prime number, Kundan? No, right? So you shouldn't get any factors apart from 1 to n, okay? Apart from 1 and 27, there are no other factors, okay, Kundan? Clear? Thank you. Okay, so this is about the prime number, guys. Okay, so you can go till 1 to n, 1 to n by 2, and sorry, 2 to n by 2, and 2 to square root of n. So in this way, if the interviewer is asking to optimize the code or complexity for prime number, you follow this approach. Gautam, are you clear? Thank you. Thank you. Okay. Okay, guys. Now you guys try for a program. Armstrong number. You know Armstrong number? Suppose 153 is there. 1 cube 1, 5 cube 125. Okay. Okay, see guys, what I am trying to do, I am fetching each and every digit. Okay, इसके बारे में I am making a cube. Okay, and making up to sum. Kundan clear? Okay, so what I am trying to do, okay, इन्होंने नंबर के लिए I am just trying to extract each and every digit. I am trying to cube it and I am trying to add up to the final sum. Okay, ठीक कुंदन. Okay, right. So guys, can you can you try writing the program for this Gautam? Kundan, can you push, can you what we call solution की कोशिश करे. Okay, please try that. Okay. Yes, I'll give you 3 more minutes. Please try that. Okay. Yeah, yeah. Okay. Yeah, yeah. 1 minute, 1 minute. The Bindu is struggling today a lot, I think. Gautam. Okay, very good. You have calculated number of digits, sir. Okay, very good. Okay, each number you are making count. That also very good. Digit by 10, clear. Gautam, what I am trying to say, assume the number has only three digits, okay? Okay. Assume number has only three digits, okay? Because yeah. Don't take for general case in the beginning. People will confuse you. Okay. If you are already aware of that one, you can go for a general case. But I suggest go for a number case three. Okay. Okay. Clear, Gautam. See what I am trying to do. I need to take each digit. Okay. Out and I need to make a cube. So if I want to take each digit out now, use modulus 10, guys. Remember that 153 modulus 10 equal to 3. 153 by 10 equal to 15. That means if you do modulus 10 with any number, you will get the last digit. If you do by 10, you will remove the last digit. Am I clear? Clear, guys? Okay, suppose 169. Okay, if you do modulus 10, how much, Kundan? Can you tell me, Kundan? Kundan, 169 बारे में if you do modulus 10, what is the answer? What is answer में क्या हुआ? Do this, Kundan. 169 by 10. Okay. 10, 16, sir. 160. Remainder is 9, na? That's it, Kundan. Clear? Ah? So if you do modulus 10, no, you will get the last digit as the answer. If you do by 10, the last digit will be removed. The 16 will be answer. Clear? Ah? Clear, guys? 159 by 9. Ah. See, don't use modulus 10 or 9. Only 10 only. Modulus 10 by 10 here. Okay. By 10 will remove the last digit. Okay. Modulus 10 will fetch you the last digit. Okay. There. Yeah, I'll tell you. I'll tell you, Kundan. I'll tell you, Kundan. Okay. What is that? Okay. Okay. See, while temp or n not equal to 0, you should go till my n is not equal to 0. What I told guys, if you want to fetch the last digit, reminder, n modulus 10. Am I correct, Kundan? If you want to remove the last digit, n equal to n by 10. Clear? Ah? In between, what you supposed to do? Sum equal to sum plus cube only. Okay, three digit only. Remainder. Clear? That's it, Kundan. What is there? Into sum equal to 0. And guys, I should compare sum with n. Is it correct answer, guys? Gautam, can you tell me? So if I write sum double equal to n, is it a correct answer or not? It is. Is it right, Gautam? Gautam, is it right? Sum equal to n is Armstrong number, else not. Is it right answer, Gautam? Being a FANG aspirant, you're not supposed to tell this, Gautam. Okay. After my while loop, what is the value of n, Gautam? N is 0. Then how can I compare? How can I compare 0 with sum? Yeah, this is what I'm expecting from you, Gautam. As a FANG aspirant, you're not supposed to tell that. Okay. We compare sum with. No problem, no problem. Yeah, Kundan, you're asking something. Tell me now. Are you clear with the score, Kundan? Sorry, Nai? 3 is an Armstrong number. Okay, guys. Guys, any three-digit Armstrong numbers? Not an Armstrong number. Yeah, see, it is not here in right, not. Okay, clear, guys. It's not an Armstrong number. Okay, that's all. Okay, na? Clear? Guys, we'll stop it here. Okay. So I don't want to start a new program. Okay. Let me stop the recording.